finally, we're asked to graph an ellipse that is not given to us in standard form, so we have some extra work to do. We're going to actually have to complete the square in order to even graph this. So let's go ahead and start by grouping the x squared and y squared x terms together and y terms together. Also note that since this has an x squared term and a y squared term on the same side of the equation with the same sign, they're both positive, but different coefficients, I know I have an ellipse. It's not a circle because for a circle, these coefficients would be the same. All right, grouping the terms together. This gives me 14x squared minus 56x plus 6y squared minus 24y equals negative 38. Looking at this, I see that I have a common factor of 2. If I divide both sides by 2, I can simplify this equation. So the numbers I'll work with will be smaller. So let's divide both sides by 2 to get 7x squared minus 28x plus 3y squared minus 12y equals negative 19. Next thing to do is to factor out the leading coefficient since it is not 1. So I'm going to factor out a 7 to get x squared minus 4x plus, over here I have I'm going to factor out a 3. That gives me y squared minus 4y all equals negative 19. I need to complete the square. So I need to get b squared divided by 4. In this case, that's going to give me 4 squared divided by 4 equals 16 divided by 4 equals 4. So over here, I'm going to add a 4. Very important, on the right, I have negative 19, and I'm adding to the left 7 times 4. That's 28. So I need to add 28 to the right. All right, over here for the y terms, b squared over 4. Again, we have a b term that is 4, so I'm going to end up with the same thing, 4. Now, here I'm actually adding 4 times 3 is 12, so I need to add that to the right as well to keep the equation balanced. This is the easiest step to mess up on. You're focused here on completing the square, and then you sometimes don't remember that you have to add the same thing to both sides. Now, working on writing this in standard form, this is going to give me x minus 2 quantity squared plus 3y minus 2 quantity squared equals negative 19 plus 12 is going to leave me with 28. Okay, so negative 19 plus 12, that's going to be negative 7. 28 minus 7 equals 21. To get this into standard form, I need to have a 1 on the right. So I'm going to divide both sides by 21. This is going to give me 7x minus 2 quantity squared divided by 21 plus 3y minus 2 quantity squared divided by 21 equals 21 divided by 21. This cancels to x minus 2 quantity squared divided by 3. This becomes y minus 2 quantity squared divided by 7, and this just becomes 1. Now I have standard form, I can do some graphing. I have a center at, let's see, okay, at 2, 2. So center is at 2, 2. That's right here. So the center is at 2, 2. So that's H and K. And I notice actually that the larger term is under the y. It's associated with the y. That tells me that this has a vertical major axis. And therefore, I'm going to keep that in mind, that it's going to be oriented this way, that the ellipse is going to end up like this instead of like this. Okay, so I have my center at 2, 2. Therefore, a squared equals 7. A equals the square root of 7. The square root of 7 is about 2.6. So it gets messy, as always, when you're working with radicals, but it's about 2.6. So what I have to do is say, okay, my vertex up here is going to be at x equals 2, and then y is going to equal 2 plus 2.6, which is 4.6. So 2, 4.6. And again, I got that by saying, okay, the length of A, the length from the vertex to the center, is 2.6. So 2 plus 2.6 gives me 4.6. Over here, I'm going to take 2 and I'm going to subtract 2.6 from it. So x is still going to be 2. Now y is going to be about here, which is 2 negative 0.6. Again, 2 is here. The length of A is 2.6, so it's going to be 2 minus 2.6. So this gives me my major axis. So I know from vertex to vertex where this ellipse is going to land. Now the minor axis, B. I know that B squared equals 3. Therefore, B equals the square root of 3, which is approximately equal to 1.7. Now I have to do the same thing, but going along the x direction, the horizontal direction. So again, this is A. Okay, now to get B, I'm going to say, okay, I'm going to have 2, and I'm going to add 1.7 to it. So that's going to give me 3.7. So it's going to land about here. In this direction, I'm going to subtract. I'm going to say I have 2 minus 1.7. So that's going to land here at about 0.3. And in the y direction, in the vertical direction, it's still going to be up at 2. So again, to get this, I said 2 plus 1.7. So that brought me to 3.72. That's this point. This point is at 2 minus 1.7, so that's 0.32. So this gives me the general shape of this ellipse, like this. So I can get a good sketch based on this equation. I took this equation and I recognized that it was an ellipse. I completed the square to get it in standard form and saw that it had a vertical major axis and that it had a center at 2, 2. I then found A to determine where the vertices would be, and then B to determine the width of the ellipse here, and then I could get a good sketch. That concludes the session of Educator.com on ellipses.